So we will continue to work on chapter 13. As we have seen yesterday, we can decompose the Newton law in several types of coordinates. We already worked on rectangular components and normal tangential components. And today we will introduce the equation of motion in cylindrical coordinates. So we know that sum of forces equal MA is a vectorial relation. And if we work in cylindrical coordinates, then we can write sum of forces vector as sum of r u r plus sum of theta u theta plus sum of z u z. And we know also that the acceleration vector can be written into components of u r u theta u z. So by doing comparison along u r u theta u z, we obtain the three scalar equation of motion in cylindrical coordinates. Sum of r equals mar, sum of theta equals ma theta, and sum of z equals to mac. Now, in a second step, we should find AR, A theta, AZ. So to find AR, A theta, AZ, we will use the previous chapter formulas. Okay? So in general, they give us R function of theta, or sometimes we find it from the geometry of the problem. Okay? Now, a very important aspect is the angles. You know that whenever I draw the free body diagram and I want to decompose my forces in a frame, I need to know what angles I do with the unit vectors. So here, for example, if you look at this problem, I have a particle moving on a path. We are applying a certain force P on the particle to force it to move. Now, we have friction force and normal force acting on it, let's say. Okay? And they gave us our function of theta, so we want to work in cylindrical coordinates. So the first step to do is to draw the axis. Okay? So for UR is directed always from O prime towards the particle along this line. So it's the unit vector of O prime P, where O prime is the origin and P is the particle. So this is vector UR. Concerning vector U theta, we know that U theta is perpendicular to UR, and always we rotate in positive direction of theta. So here, the positive direction of theta is the counterclockwise. So you go from UR to U theta by turning 90 degrees into the counterclockwise direction. Then we get vector U theta. In case it's a 2D motion, no need to put UZ. In case it's a 3D motion, then we put vector UZ and we have UR U theta UZ. UZ is perpendicular to the plane of UR U theta. Now, if I want to work in this frame UR U theta, I should know what is the angle between the normal and UR and the friction and UR or U theta. Okay? This is why we will define what is called the angle between UR and the tangent to the path. Why we will do this? Because in general, the tangent line to the path is very important because a lot of forces are or perpendicular to this line or along this line. So for example, if you consider this example, the particle is moving along a path. The friction will be opposing motion along the tangent line, while the normal, which is perpendicular to contact, will be perpendicular to the tangent. So in order to decompose N and F on U or U theta, I need to know what is the angle between the tangent line and UR or U theta. This is what we will develop together now. So our purpose now is to find what is the angle psi between UR and the tangent line, and the angle psi is counted as positive in the counterclockwise direction from UR towards the tangent line. Okay? So now we will see in detail how to calculate this angle. I will zoom a little bit the figure. If you look at the figure here, we consider two positions of the particles that are very close to each other. So let's say this is position 1 here, okay? This is position 1, this is position 2, okay? At position 1, the vector position is r. At position 2, the vector position will be r plus dr, يعني a certain small displacement in r. Now, concerning the theta also, when I go from one position to another, I am doing a small angular displacement d theta. And since the displacement is very small, I can consider that the tangent to the path here is the same, since I have a very small displacement. Okay? And my purpose is to find what is the expression of this angle psi. So you can see from your figures that because d theta is very small, so it's nearly, d theta is nearly equal to 0. Because it's nearly equal to 0, then I can say that the two lines r of r and r plus dr are nearly parallel. Okay? This is why this angle here will also be equal to psi, because there are two alternating angles, since I can consider these two lines parallel. So the angle here in colored, the colored angle here is equal to psi. Okay? Therefore, if I work in this small triangle, I can write that tangent of psi is equal to this side over this one. Okay? What is the length of this side here? You know that when I have a very small displacement, I can consider that the segment is nearly equal to the arc of circle of radius r here. Okay? So I can approximate this length by r d theta. Therefore, I can write that tangent of psi is equal to r d theta over dr. Okay? Now, if we want to play with the formula, we can take d theta, we can divide by d theta the two terms. Okay? Then we get that tangent of psi is equal to r over, so here it's r over dr by d theta, where dr by d theta will represent the derivative of r with respect to angle theta. Okay, so from now on, if you have r function of theta and you want to find what is the angle between ur and the tangent line, you can use this form. Okay. Another possibility also is the following. Look, I know that tangent psi is r d theta by dr. So if I divide by dt here, the upper term, and I divide by dt also the term here, then I can use another formula also for tangent psi, that it is equal to r theta dot over r dot. So it depends on what you know in your problem. Okay, if you just know r function of theta, it's easier to use this one. If you know the value of theta dot, this is theta dot. Okay, derivative function of time, and you know the value of r dot, then you can use the second option. So here you have several possibilities to calculate tangent psi. It depends on what you know in your problem. So dr by dt here is r dot. Okay, so or you use r over dr by d theta, or you use r theta dot over r dot. Okay, so now we will do some problems to see how to apply this. So of course, remember these formulas we have developed in the previous chapters. They will allow you to calculate the expression of AR, A theta, and AC. Okay. Let us consider a first example. The smooth 0.5 kilogram double collar can freely slide on arm AB and the circular guide rod. If the arm rotates with a constant angular velocity of theta dot equals to 3 radian per second, determines the force the arm will exert on the collar at the instant theta is equal to 45 degrees. Motion takes place in the horizontal plane. So let us see what do we have here. We have a circular rod and a double collar is joining rod AB to the circular rod, and we have that the rod AB is turning at constant angular velocity of 3 radians per second. And our purpose now is to determine the force the arm will exert on the collar. Okay? Now, the first step here they helped us and they told us that R is function of theta and they gave us the function. But we should be able to do it without giving, if they don't give it, we should be able to derive. How to derive this relation? Who can tell me, if you see this figure, how you can demonstrate that the expression of R is 0.8 cosine theta? You should use geometrical technique to demonstrate this. First, what is R? What is R here? R represents the distance between A and C. Okay? So this distance here, the position vector from A to C is R. Okay? So AC represent R. This is R. And theta is the angle between AC and the horizontal. Since you have here a circle, okay, if you extend the diameter in here, this is the diameter of your circle. Then if I draw the perpendicular, here this is a triangle that is inscribed in the circle. So you know that if I have a triangle inscribed in a circle, and one of its sides is the diameter of the circle, then I can say that the triangle is a right triangle. So here I have an angle of 90 degrees. And because I have here an angle of 90 degrees, then I can say that R is equal to the hypotenuse times cosine theta. Okay, and the hypotenuse is equal to the length of the diameter. So R is equal to 0.8 cosine theta. So even if they don't give me the function, I can find it. Okay. Now, since I can find R function of theta here, so the easiest coordinate to work with is the cylindrical coordinate. So the first step now, I should put my unit vectors for the cylindrical frame. I have first UR. UR is along AC. Okay, it's always the unit vector of a position vector R. So this is vector UR. To obtain vector U theta, all I have to do is to rotate from UR in the positive direction an angle of 90 degrees. So I will do the perpendicular turning in the here. The positive theta is like this. So it's counterclockwise. So this is U theta. Okay. Now, once I represented my vectors, okay, the second step is to draw my forces. What are the forces acting on the color C, on the double color C? Who will tell me? What are the forces acting on C?
الويت والرياكشن تبع الكولر.
Exactly. We have the weight. Okay. هلا الcolor C is attached to the rod. Okay. And is attached to the, يعني you have two rods to which the color is attached. So pay attention. We should consider the action of the rod and the action of يعني of the linear rod and of the circular rod. First, we have the weight. Okay. This is the weight of the double color. Okay. Now, the arm AC is doing an action on the color perpendicular to contact. This is the contact line. This is the contact line, okay, between the two. So the force will be perpendicular to the contact line. It will be along the perpendicular to AB. So this is, هلا we will see the free body diagram again. يمكن it's a little bit complex here. هلا حنرجع نشوفه again, okay? So this is the force F exerted by arm AB on the collar. And don't forget also that you have contact between the circular rod and the collar. Okay. بس في شغلة. الويت أنا حطيته مظبوط in this figure. Who will tell me? أنا حطيت الويت vertical. It is right that the weight is vertical here.
نو لأنه هذا horizontal يعني بده
Very
يكون
good. كتير انتبهوا للgiven. Yes, you should pay attention for the given. It's very important to know what is the type of view. If it's a top view or a profile view. This is a top view because they said that the plane is horizontal. Please كتير بيغلطوا فيها التلاميذ انتبهوا لها. Okay, so في كتير دغري بيفكروا vertical plane بيحطوا W like this. It's wrong because it's a horizontal plane. If you want to represent W, it will be like this. It's an X because it's inward. So this is W. يعني here it's not in the plane of motion. And W is opposed by a normal reaction from the rod. يعني حسميها NZ إذا بدكم. It will maintain it in equilibrium in Z direction. So this is NZ. نحن الويت والNZ ما حيأثروا على الموشن تبعنا. They are in a perpendicular plane to motion. So let me go to another figure for you. Okay. So this is the free body diagram. الويت والNZ perpendicular to the plane. So no, you can put them, but they will not affect the equation of motion. And you have also the force between the circular rod and the collar. يعني إذا بتطلعوا بهالcollar, it's a double collar. So here, this line is the contact line with the linear rod. And you have also a contact line with the circular rod. Okay, والcontact line with the circular rod بتكون along the tangent. So if I go back to the figure here, the normal between the circular rod and the collar will be perpendicular to the contact line. هيدي الcontact line, let's say. Okay. Then it is the contact line between the collar and the rod, هي التangent to the circle. This is why your force, your normal force between the circular rod and the collar will be along the radius. Because in a circle, the radius is perpendicular to the tangent. Okay? So here, in this way, you can calculate the angle. Let me draw it for you here. So here, this is your circular rod. Okay? We said that the normal should be perpendicular to the tangent. So this is the tangent to the circle at this position. So the normal will be like this. Now, since here I know that the angle theta in this problem is 45 degrees, okay? So if I represent my position vector, this is the position vector. They said that the angle theta at this instant, for which we want to do the calculation, is 45 degrees. So since the angle here is 45, and UR is along this line, okay? So this is vector UR. Then we can say that the angle here also, this angle is 45, okay? So the angle between UR and the normal will also be 45 degrees. And this angle here is also 45, okay? So here, if you look at your figure, this is UR, this is U theta. The normal is doing an angle of 45 degrees with UR and 45 degrees with U theta. And the force F is perpendicular to this line. So it's perpendicular to UR, okay? Because it's perpendicular to the arm. Now, once you draw the free body diagram, it becomes very simple to continue. And the most important step is to draw your free body diagram and to put your forces. Once done, you just have to do projection along your unit vectors, UR and U theta. Okay? So I will start first by the first Newton relation. Sum of R equals MAR. Along UR, what do I have? If you look at your figure, F is perpendicular to UR, so no component along UR. I only have the component of the normal along UR. And since the projection of the normal on UR is negative, so it's downward here, then I do minus NC cosine 45 equals to MAR. And how to calculate AR? AR is R dot dot minus R theta dot square. So now we will, in another step, we will calculate AR and A theta. So this is our first relation by projecting along UR. The second relation is to project along U theta. And I will fix it for you. This is sum of F theta equals MA theta. So here is the second relation. When I project on U theta, what do I have? If I look at my figure, I have also a downward projection of n on U theta. So it's minus n sine 45, or cosine. It's the same here because the angle is 45. And plus f. So now I have two equations with two unknowns, which are nc and f. But in order to be able to calculate f, I should find first the expressions of AR and A theta. Okay? So now I will apply the formulas. R dot for AR, it's R dot dot minus R theta dot square, and for A theta is R theta dot dot plus 2R dot theta dot. So as you can see in the expression of AR A theta, I need to find R dot dot, theta dot, and theta dot dot. To do this, first I will start with the expression of R. What is R? R is given to be 0.8 cosine 45. 0.8 cosine theta. So here they directly replaced, and I will do for you the derivation. Okay. So you have that R is given by 0.8 cosine theta. So if you want to derive this relation with respect to time, هنعمل chain rule. Okay, so R equals 0.5 cosine theta, then 0.8 cosine theta. Then the first derivative هتكون 0. minus 0.8 sine theta theta dot. مظبوط. So this is why here they directly replaced by the value of theta, and we are interested just at 45 degrees. So when you replace in R dot minus 0.8 sine theta times theta dot, you have theta is 45 and theta dot is given to be 3. So you can get the value of r dot. Now, for r dot dot, you will derive minus 0.8 sine theta dot. Okay? But since theta dot here, so this is theta dot, and this is sine theta. Okay, so always first derive, then replace. Okay? Now, they said in the problem that theta dot is constant. This is why theta dot dot will be 0. Okay, so it's not. It's like here that you only have a constant times sine theta. So the derivative will be restricted only to sine theta. The derivative of sine theta with respect to time is cosine theta dot, and already I have theta dot. So the result will be minus 0.8 cosine theta dot square. So if you replace, it's minus 0.8 cosine 45 times theta dot square, which is 3, so times 3 square. Then you get the value of r dot dot. Now, in case theta dot was not constant, you derive like you have a product of functions, u times v. So if I have u times v, it's the derivative is u prime v plus v prime u. So the derivative will be then minus 0.8 sine theta dot dot and minus 0.8 cosine theta dot square. But here, since this is theta dot dot, it's 0. So the first term will simplify, and you will only have that r dot dot is minus 0.8 cosine theta dot square. Now we calculated r dot, and r dot dot at the angle desired, which is 45 degrees. Now, concerning theta dot dot, it's 0. So now we have everything. We are ready to calculate the values of AR and A theta. We know that AR is given by r dot dot minus r theta dot square. So all we have to do is to replace by the values of r dot dot and r dot and theta in AR. And for A theta it is r theta dot dot plus 2r dot theta dot. So also by numerical replacement, we can get the value of eta. Once we have the values of AR and A theta, now we can move to our system. We can go back to our system and calculate the value of the force. So they asked us to calculate the force of the collar, of the arm on the collar. The force here is 0. So at this particular position, F is 0 and NC is 0.75 in Newton. And you know that these forces will vary with theta. So for each angle, you will have a new value for these forces. Okay? Any question on this problem?
دكتور
Yes.
this problem فينا نجيب بساي
ايه هلا in this رح نعمل بروبلم تاني مع بساي، بس تعرف هون ما عزنا نجيبها. you know why؟ لأنه الجيومتري is simple. اوكي؟ يعني إذا بدك حنجيبها together بس no need to find it. حنشوف حنتأكد إنه بتعطينا نفس الجواب. If you go back to your figure, what is psi here? Psi here is this angle between UR and the tangent line. So هون حيطلع a negative angle. This is psi. Okay? How to calculate psi here? You should use the formula. The formula is that tangent of psi is equal to r over the r by d theta. مظبوط? Okay, so let us apply it here. What is r? R is 0.8 cosine theta. So I replace r by 0.8 cosine theta. And what is the r by d theta? You know that tangent psi is r over the r by d theta. Okay? R is 0.8 cosine theta, while the r by d theta is, so if I divide by the r by d theta, It's the derivative of r with respect to theta. Please pay attention. If you use this formula, dr by d theta, it's derivative with respect to theta, not with respect to time. Yani it's minus, it's minus 0.8 sine theta. Okay? So here, as you can see, 0.8 will simplify. And then you will have cosine theta over sine theta, which is 1 over tangent theta or cotangent theta. Okay, so here you are interested at which position to calculate psi. You are interested to calculate psi for theta equals to 45. So if you replace theta by 45 in this relation, what do you get? You get minus 1, because cosine 45 equals to sine 45. It will simplify. You get tangent psi equal to minus 1. So psi is minus 45 degrees. So this will give you that this angle is 45. And you can deduce then, since the normal is perpendicular to the tangent, that this angle will be 45. But here, why we didn't calculate psi? Because from geometry, we know that if we have a circle, the perpendicular to the tangent line is along the radius. So since we know that n is along the radius, and we have here at this position, the radius is perpendicular, is in the vertical position, then we know all angles here. So no need. So we know here that this angle is 45. So no need to calculate psi. Psi, you use it when you cannot find the angles by other geometry techniques. And we will see an example of this now. Okay?
Okay, doctor, thank you very much.
Yeah. So let us do another problem where we will use psi. Okay. So here, a can C having a mass of 0.5 kilogram moves along a grooved horizontal slot. The slot is in a form of spiral defined by the equation r equals to 0.1 theta, where theta is in radian. If the arm OA is rotating at a constant rate theta dot equals to 4 radians per second in the horizontal plane, determine the force it exerts on the can at the instant theta equals to 5. So here, in this problem, it's similar in concept to the previous one. Okay, we have our function of theta. We have a ball connected to in contact with an arm and in contact with the path, and we want to calculate what is the force of the can on the ball at this instant. Okay, so first, since they gave us our function of theta, we will work in cylindrical coordinates. So the first step is to put our unit vectors. You are always directed from origin towards the point. So if I want to represent UR here, this is UR. And U theta is the vector perpendicular UR by turning plus 90 degrees in the positive direction. As you can see here, the positive direction is counterclockwise. So I will rotate in the counterclockwise, and then this is U theta. Okay? So this is UR. And here again, it's a 2D motion, so we will not need UZ. Okay. Sum of forces along Z is 0. Now, also here it's a horizontal plane, yani the weight and the normal along Z, okay, will be perpendicular to the plane. So if you want to put the forces, the remaining forces in this plane, what will be our forces? What will be the forces in the plane acting on ball C?
F and NC.
Yes, exactly. It's like the previous problem. You have this ball is in contact with the arm here. So this is the contact line with the arm. Then the force F of the can on the ball will be along u theta perpendicular to UR. So this is the force F. Now, concerning the grooved path, look, if they ask you in the exam, find the total normal force of the grooved path on the can, you should find two things. You should find NZ, because here the reaction of the grooved path on the ball is divided into two parts. You have NZ that is opposing the weight, okay, and you have, so which is perpendicular to this plane, and you have the normal N, okay, that is in the plane of motion. And N here will be perpendicular to contact, okay? And the contact here is along the tangent to the path. So N will be perpendicular to the tangent. So here we should find the psi, because here the tangent direction is very important. So we should find what is the angle between UR. This angle between UR and the tangent is psi. So here we should calculate psi to be able to project our normal force, okay? Because our normal force here is perpendicular to the tangent line. So this is our normal force, N. And if they ask you for the total reaction of the grooved path on the ball, then you say that once I calculate NZ and N, I have that the total reaction will be radical of NZ square plus N square, okay? So just pay attention here that you have two types of reactions, one in the plane and one perpendicular to the plane, okay? Now, since here, as we said, the normal is perpendicular to the tangent line, then in order to project N on U theta UR, we need to calculate the value of psi. So let us see another clearer figure together and see how to do our calculation. So this is the free body diagram that we did together. Look, concerning NC, you should do an assumption. It can be up or down, okay? You cannot always predict before your calculation how would be N. It's not a problem. You do an assumption. And for example, here they considered NC is upward. So you do your calculation. If you get positive result, this means that your calculation is right. If you get negative result, it means that it is up. Here النورمال فيها تكون in both directions. Why? لأنه حسب البول وين عم بتلقي على الباس. So you have the path, the grooved path is like this. This is your grooved path. And this is your ball. Okay, look. The ball can be supported by this part. يعني إذا هي عم بتشد على هالpart, then the normal will come from here, like this, downward. Okay, and in case it is supported by, يعني إذا عم it is exerting a force on this side, ساعتها بتصير normal in the opposite direction up. So we cannot expect this. This will depend on the position, okay, of the ball. So here we can do an assumption, and from the calculation we will know if N is in this direction or not. Okay, in this sense إذا بدكم يعني لأنه هي same direction but it can be in opposite sense. So now, as we said, the normal is perpendicular to the tangent, okay? And we know that from the course material that we can calculate easily this angle. If you know the angle psi, okay, then you can say that this angle psi will be the same angle between the normal and U theta. Why? Because if you look at your figure, so here N, between N and U theta, it will be equal to psi. You can demonstrate this in several ways. The first way is, as you can see here, UR and U theta are perpendicular. So if this angle is psi, this angle will be pi over 2 minus psi. Here they called it phi angle. And since the tangent and the normal are perpendicular, and هيدا 90 degrees, if this is phi, اللي هو pi over 2 minus psi, then this angle will be equal to psi. And the angle between the normal and UR will be phi, or pi over 2 minus psi. Okay? Another method is to say that the normal is perpendicular to the tangent line, and u theta is perpendicular to ur. So we can deduce that the angle between ur and n is equal to the angle between the tangent and u theta, which is phi. So also this is another method to demonstrate أن الangle between n and ur هو phi or psi or pi over 2 minus psi, and therefore the angle between n and u theta will be equal to psi. So the first step now is to calculate psi, which will allow us to do the projection of the normal on ur and u theta. So since we have r function of theta, r is equal to 0.1 theta. Okay, so this function is given to be 0.1 theta. Since we know r function of theta, if we derive r with respect to theta, dr by d theta will have 0.1. Okay, so it will be 0.1 theta over 0.1, and then 0.1 will simplify, which will give us that tangent psi is equal to theta. Okay, so in this way we have calculated the general value of tangent psi for any angle. Now, since in particular we are interested at position theta equal to pi, what will be the value of psi, then we will replace in the formula. Please guys انتبهوا على طول هون you replace الانجل theta by value in radian مش value in degrees. يعني don't do tangent minus 180, you will get wrong results. Okay, it's tangent minus 1 the angle in radian. This will give you that psi here is 72.3 degrees and phi is 90 minus psi equals to 17.7 degrees. Okay, so now once we got these angles, it becomes very simple. All we have to do now is to project along ur and u theta. So if you look at your figure, if I do sum of r, the force Fc is perpendicular to ur, so no projection along ur. I only have the projection of Nc. As you can see here, the projection of Nc on ur is a positive projection. So it's plus Nc cosine phi, this angle, equals to MAR, and AR will be calculated as r dot dot minus r theta dot square. While for sum of theta, if I do sum of forces along u theta, I have the force Fc, which is along u theta, so plus Fc, and for Nc, it's a negative projection also, so it's minus Nc sine phi. Okay, so let us see the equations together. So by doing the projections, we get two equations with two unknowns. The two unknowns are Nc and Fc. Now, in order to solve the system, we should calculate AR and A theta. So also same method. We will use the formulas derived in previous chapter. So we should do our derivations. Here it's simple. We have R equals to 0.1 theta. So R dot is 0.1 theta dot, and R dot dot is 0.1 theta dot dot. But since theta dot is a constant here, then theta dot dot will be equal to 0. Okay. Now we still we have everything now. We can replace into the expression of AR and A theta by replacing all variables by their values for theta equal to pi. We get AR and A theta, and then we can solve our system of unknowns to get Nc and F. If they only ask for F, just find F. Okay, and sometimes if you can reduce the calculation, do it. Okay, any question on this? Okay. Now, the final part in this chapter is the central force motion and space mechanics. Okay, هيدي البارت فيها شوية كونيك. هلا maybe today ما حنلحق to go over all details. Next time I will demonstrate for you in detail everything. Just today we will go over يعني we'll do an overview on it. So what is the definition of central motion and space mechanics? So here when we say we have a central force, this means that if we follow the particle is only subjected to one force during its motion. And this force is always directed towards one point. This is the definition of central force. Central force is very important in space mechanics because all satellites motion is driven by functions of equations of central force motion. Okay? So if a particle is moving under the influence of a force having a line of action, which is always directed toward a fixed point, then the motion is called central force of motion. So if we consider a figure here, if you consider this figure, you have a particle P moving on a path, and the force acting on P is always directed towards one fixed point, okay, which is here's the origin. Then we will use, in this case, to define its motion, we will use cylindrical coordinates. Why? Because here we have one origin, okay, that is fixed, and the position vector R is changing in direction. So this is why we will use cylindrical coordinates. So then we will take a line passing by the fixed point. This will be our reference. So you will have a reference line. So this is the reference line. Okay. And theta is the angle defined between the reference line and the position vector. So this is theta. Okay. And now, at any position of my particle, it will be subjected to a force passing by. Okay. So we will derive together the equation of motion in this case. To derive the equation of motion, first we will set the coordinate system UR, U theta. Okay. So UR is always directed from O towards P. So this is UR. And U theta is perpendicular to UR. So this is U theta. Okay. And as you can see here, the only force acting on my system is F. And it is directed towards, along UR, in opposite direction, towards O. This means that sum of theta will be 0. Okay, so this is a particular case because I only have always my forces along UR. So A theta will be 0. And I will use the projection on UR U theta to derive the equation of motion in my problem. Okay, so the first relation which I can derive is by writing that sum of R equals MAR. So here, if I write that sum, yeah, just one second, the text please. So if I write that sum of forces along UR equals to MAR, I just have the force F. So I get minus F equals to the mass times AR. And AR, I can calculate it from previous chapter as R dot dot minus R theta dot square. And concerning projection along U theta, I'll have that sum of forces along theta equals to 0 because I don't have any force along U theta equals to MA theta. So I deduce that A theta is 0, and I know that A theta is given by theta dot dot R theta dot dot plus 2 R dot theta dot. So this will give me a relation between if you want the variables of motion. Okay, so let us see in detail what are the conclusions I can make in this type of motion. So as we said, the first step will be to apply in polar coordinates the equations of motion. This is the first relation along UR. Along UR, I obtain minus F equals to M times second derivative of R with respect to time. This is R dot dot minus R theta dot square. This is the expression of AR. While for along U theta, I have that sum of theta equals to 0. So A theta is 0. And A theta is R theta dot dot plus 2R dot theta. Okay? Now, if you play a little bit with the form of this relation, هيدي الريليشن فيكم تكتبوها إنه هي الدerivative with respect to t of r squared d theta by dt. خلينا نجربها أنا وياكم. If you derive this relation with respect to time, what do you obtain? كأنه عندكم هون a product of two functions. Okay? u times v. صح؟ ال u هي r squared. ال v هي d theta by dt. If you derive this relation شو بيطلع لكم؟ بيطلع لكم 2 r dot theta dot مظبوط اللي هي إذا بدكم هي هون بس مع 2 r يعني 2r times r dot لأنه الديريفاتيف of r square هي 2r r dot times theta dot. اوكي واذا بتعملوا 1 over r برا بتصير بتروح ال r بس بضل في 2r dot theta dot. طلعوا بهيدا الترم هيدا 2r dot theta dot. Now the second term هو uv prime. uv prime هو r square theta dot dot. If you divide by r 1 times 1 over r بيطلع لكم r times theta dot dot which is the following term. يعني I can replace this term by 1 over r times d by dt r squared d theta by dt. And this means that since r is not 0, this means that the derivative with respect to time of r squared d theta by dt is 0. Therefore, r squared d theta by dt is a constant. Okay? هيدا البارامتر r squared d theta by dt can be related to the what we call the real velocity اللي هي areal velocity اللي هي the variation in swept area per unit time. شو قصدنا بال swept area per unit time? If you go back to the figure here, okay, when you move, you will go over a certain area. This is the swept area for a certain time dt. Okay, we will demonstrate together إنه dA by dt is constant. يعني for a certain amount of time, if I go over the